All right, so you're just getting your feet under you with derivatives and how to find them, and now I'm gonna throw at you that there's a second derivative, and a third derivative, and a fourth derivative. What? All right, they're not as hard as they sound. But basically, we have higher order derivatives because really, the derivative is really just a function, right? So if I find the derivative of x squared and I find out that it's 2x, well, 2x is a function, isn't it? Well, can I find the derivative of a function? Yeah. So I could just find the derivative of the derivative, and then I just have the second derivative, okay? So my first derivative is the first time I take the derivative, and then I take the derivative of that to get the second, then I take the derivative of that to get the third, and the derivative of that to get the fourth, okay? And our notation, there's all these different notations that you could understand. We use this one a lot, y prime, y double prime, y triple prime, y quadruple prime? Yeah, I've heard that a few times. Or f prime, f double prime, f triple prime. These notations, for instead of dy dx, we use those notations with f of x. So all of those different notations could show up, and so it's important for you to understand what they're talking about when they actually say, when they show that, and it's also important for you to know how to write those, because these ones are a little challenging because the squared doesn't go in the same spot. You see one at like D, actually you probably can't see that because there's a glare, I'm sorry. I tried to get rid of the glare and I can't figure out how to have the projector and no glare, so we get glare, sorry. All right, so you have the squared on top and bottom, and just remember where to put it. Okay, so let's look at what this actually looks like. Let's find some second derivatives. Okay, so if I have f of x equals, you know what, let's do a super easy one that's not in your notes first, okay? F of x equals x to the fifth plus x to the third. Okay, let's find derivatives of this. This should be really, really quick with our derivative rules, right? Okay, so f prime of x would be 5x to the fourth plus 3x squared. Okay, so our first derivative is this. F double prime, we bring the 4 down and multiply it, so we get 20x cubed plus 6x, because I took the 4 down and multiplied it by 5, and then I subtract 1 from 4 and get 3. I bring the 2 down and multiply it by 3, and subtract 1 from 2 and get 1, okay? F triple prime of x equals 60x squared plus 6, because I take the 3 and multiply it by the 20, and then I subtract 1 from that, and then I have a 1, right? I have an invisible 1 here. I take the 1, multiply it by 6, and I get 6, and I subtract 1 from this, and I get x to the 0, which is 1, okay? And one last, quadruple prime, we're going to have 120x plus 0. So this would be all of our higher order derivatives, and like you can see that a lot of times, with a polynomial at least, eventually you're going to get to 0. Now you're asking yourself, why in the heck do I care about all these extra derivatives? Well, they tell us a lot about the function, and later, soon, we're going to use the first and second and third derivatives to tell us about the function and what it's doing, and so we actually need to know how to find them. So let's look at your notes. Let's try this one. Okay, so f of x equals 1 over 2 times the cube root of x squared, and I need to find f prime of 1 and f double prime of -8. Okay, so let's just find f prime first. F prime of x, well, actually, let's rewrite f of x first, okay? Because right now, it doesn't look very easy to differentiate, okay? So, f of x equals, let's split our fraction, 1/2 times 1 over the cube root of x squared. Now f of x, then we could go 1/2. Well, how can we write that as a power? Well, that's 1 over x to the 2/3, right? Because cube root of x squared is really just x to the 2/3. And then one more rewrite, f of x equals 1/2 x to the negative 2/3, okay? So now it looks like something we can do the derivative of. We're gonna take our exponent, we're gonna bring it down. Take our exponent, we're gonna multiply it down here. So we're going to get f prime of x equals negative 2/3 times 1/2 times x. And then we take this exponent, we subtract 1 from it. Negative 2/3 minus 1 is negative 2/3 minus 3/3, so it's negative 5/3. Okay, so this right here is my first derivative. And we'll go ahead and multiply that out so we get negative 1/3. Okay. So now it says, let's find f prime of x, f prime of 1, which basically means you found the equation of your tangent line. This tells me I could put any x in and find out what the slope of my tangent line is. Sorry, not the equation of my tangent line. This is the equation of the slope of my tangent line. But now I want to take any x and put it in there, and then I can get out the actual slope at that exact point, right? Because our rate of change is constantly changing. It's not a constant because we're looking at curves now. Okay, so f prime of 1, well, I plug 1 in for x and I get negative 1/3 times 1 to the negative 5/3. Well, 1 to anything is still 1, so I have negative 1/3. F prime of positive 1 is negative 1/3. Now I want to find my second derivative, and I want to find its value at negative 8. So I've got to just find my second derivative. So my first derivative is negative 1/3 x to the negative 5/3, okay? Now I need to find my second derivative. Well, it's already written in a very nice format. So all I have to do is take my exponent, bring it down to multiply. So f double prime, I should change my notation there. That is f prime still. Now f double prime of x is going to be negative 5/3 times negative 1/3 times x to the, well, negative 5/3 minus 1 is negative 8/3. So then I just multiply these together and I get positive 5/9 times x to the negative 8/3. So this is f double prime, okay? So f double prime equals this mess, and I want to find f double prime of negative 8. Okay, now if this is on a calculator portion, you put this into your calculator in your y equals screen, and then you just evaluate it at negative 8. If this is one you don't have a calculator for, you do 5/9 times negative 8 to the negative 8/3, and you circle your answer, and you're done. Okay, you don't have to figure out that mess. It's a lot, and your algebra will probably get you on that. So we're in calculus. We don't have to simplify unless we need to find a value to use for something else. So f double prime of negative 8, this is the slope of the tangent line to the derivative. So this is the second derivative of our function. That's our value.